So for questions number 1, it wants us to determine the magnitudes of force 1 and also force 2 for equilibrium. So when you guys see the term equilibrium here, so you guys just need to break down the force components into some uh some of force in the x axis and y axis equal to 0, and then from there you guys can find the magnitudes. who have completed answering the questions number 1, can you guys share your answer? If possible, can you guys share how you guys uh, do the steps? Maybe through picture or screen, or typing the answer in the chat. Anyone? Do you guys have any problem with questions number 1? So we will discuss the answer together. So for questions number 1, they want us to find the magnitudes for F1 and F2 in equilibrium state. So the theta is equal to 55 degree. Okay, so for this kind of questions, what you guys need to do is you guys have to break down all the 4 forces here into into a force in x direction and also in y directions. Do you guys get the answer for F1 and also F2? Can somebody share the answer? So if nobody shares the answer, thank you for sharing your answer, and your answer is correct. So basically, I'm going to explain how we get the answer to the questions. So basically, give me time to redraw this again. Okay, sorry for the graph not looking straight, but we will just move on. So basically, first you guys have to break the forces into components fx and also fy. So for fx, you guys have to, so negative 5 cos 30. This one you guys take this measurement from here, from this part. Do you guys can see my cursor moving or not? I'm not sure whether it's visible to you guys or not, but so this is the part where we get 5 cos 30. It's in the negative signs because it is in the negative axis of x, and then 7 times 4 over 5. Here we take from this part, and then plus f2 sine 70, and this one we take from this part, and also f1 cos 55. This one we take from this part. Okay, so and then you rearrange all these numbers to get f1 equal to 17.3117 minus 1.6382 f2. So this is the first equations, and then we next go to force in the y direction. So so upward is positive. So again, for fy force, we get 5 sine 30. This one we get from the upper left here. Oh, really? You cannot see the cursor? Mm, okay. Okay. So for fy, uh 5 sine 30. So you guys take from this part, and then you minus with 7 times 3 to the 3 over 5. You take this reading from here, and then plus f2 cos 70, this one from here, and f1 minus f1 sine 55, this one from here, and equal to 0. So this is the second equation. So when you guys sub first equation into the second equation, you guys can easily get f1 equal to 1.86 kilonewton and f2 equal to 9.43 kilonewton. So are you guys clear with the answer? If you guys have any questions, oh, guys may ask.
Miss,
Yes.
so for this question, we have to use substitution, right?
Yes, substitution only. So so you guys only need to do two things in here. The first one is break down the forces, and second substitute.
Okay. Thank you, Miss.
Okay. Any other questions? So if you guys don't have any other questions, so we move on to the second questions. So this is the second question. So you guys can take about 10 to 15 minutes to solve the problem, and then we will discuss the answer to the questions together after this. Okay, so for questions number 2, also as same as the number 1, you guys just have to first draw the body diagram, and second, you guys break the forces components into forces in x direction and y directions. Uh, that's only. And then from there, you guys can get the distance between x and y. Just now substitution, I only did that, so there is no substitution in second equation. Do anyone already found the answer to questions number 2? Oh, okay. If then, do you guys need more time or should we discuss together? Okay, we will, if anyone found the answer, okay, we will discuss this together. Okay, so we will discuss this together. So as I mentioned previously, so we have to break down the forces into components in x direction and also in y directions. So first we will try to solve in y direction first. Okay, before that, let me explain to you about the body diagram. So basically we define the B as at the coordinate 0, 0 here. Okay, so to the right is the direction of force 2 equal to 1000 Newton, and as you can see on the left side is the direction of forces from B to C and also B to A. So as you can see, C today is force number 1, the F1 equal to 800 Newton. So as you can see, A, B, C, D, they are sharing the same pulling force. So that's why for the direction here and also here, both F1 equal to 800 Newton because they share the same chord and also the same pulling force. So from there, we break down the forces. Uh, so in the diagram, they did not specify the theta 1 and theta 2. So we just mix the assumption by ourselves. So this one is theta 1 and this one theta 1 and this one theta 2. So basically, negative 800 sine theta 2 is the part bottom here because the y in negative y-axis and 800 sine theta 1 is the part here. So plus 800 sine theta 1 equal to 0. So when you solve this, you may see that both is actually the same value. So this makes that theta 1 is actually equal to theta 2. So this is up until So for F force in the y-axis is up until here. Theta 1 is equal to theta 2. And now we solve for force in the x direction. So 1000 is the force for F2. And then you guys minus with 800 cos theta 2 minus 800 cos theta 1 equal to 0. So both here is minus because both in the negative axis of x-axis. Then you solve this question. Why is the acting to the left? Because in the equations diagram is acting to the right. Which force do you mean? F1? Oh, for F1, because this is in equilibrium condition where the total sum of the forces should be equal to 0. So let me draw it. Okay, let me show you first. Okay, as you can see the equilibrium, this is in the equilibrium state. So what does this mean? That when it means the state of the thing should be in the total sum should be equal to 0. So that means when this is the force here, so that means the opposite force should be in this direction for this to be equal to 0. And if this is equal to, if in this, so this is F1. So to make it this equal to 0, the force should be acting in opposite direction, which is this one. So for this one B to be equal to 0, the forces should acting opposite to force here. So it should acting like this one. And since the force for the force this direction, so the force at this direction should be opposite to this direction, and this should be the direction force here should be like this one, because you want to make the forces to be equilibrium, so the sum of the force should be 0. So any force that share the same pooling chord like this one. So each point, the direction of the forces should be opposite to each other. Do you get? Are you clear? Okay. So we continue with our. Okay. Okay. So this one I make it just theta because from the upper here you can see theta 1 is equal to theta 2. So we can just assume this to be one angle cos theta. So equal to 0. So when you solve this equation, you can actually get theta is equal to 532. So which means that this also the angle for theta 1 and this also angle for theta 2. So that means they are equal to each other. So now that now we know that we know the angle. Now we solve the distance x and also y distance. So we draw this again. So since both angle is equal value, and this is y and this is 2 up until here. Okay, and then x is supposedly to be here, so that means it's also actually at this position because they are at the same line. Okay, so this one you actually you can just use tangent. So when you solve this, you guys will get 1.6 meter. So this one is 1.6. Okay. So this is the answer to questions number 2. X equal to 1.6 meter, Y equal to 2 meter. So are you guys clear with the answers? Okay, so I assume everyone understands. So now we proceed to questions number 3. Okay, you guys can take 10 minutes to solve the problems and then we will discuss this together. Since we're kinda have time constraint, so we will discuss these questions together. Or is there anyone have completed the questions? If no, if anyone has completed the answer, you guys can share the answer. And in the meantime, if no, we will discuss this together. So basically, in the questions, you guys can see they are actually okay, as you guys can see in the diagram. So basically, you guys can see so many chord right in here, right? So there are actually here there are 3 different points that you guys have. It means that you guys have to draw 3 different 3 separate free body diagram. So the first one would be here. Okay. So this is the free body diagram for the pipe here. So this would be W equal to W, and then you should have uh, opposite forces here, and then this is the first body diagram, and the second one is the one at the point A. So at the point A, this is the force AE, and this is the force AH. Okay, this is the force AH. So the force AH is pointing downward, as you guys can see, because the pipe below there, okay, is pointing upward. So the please remember this is equilibrium state. So forces, the one that share the same chord should have opposite direction of force. Okay, and then we have here AB pointing here. So now when we draw the forces at B point, so for BA, it should be opposite to AB. So it should be like here. Okay. And then the direction of force BD should be like here. And direction for force BC should be like here. Okay. So when we redraw these forces into 3 separate diagram, it should look something like this. Okay, so this is how it should looks like. Okay, now to find the forces, we have to break them into components in x direction and also in y directions. But since we have three separate free body diagrams, so that means we have to solve the forces individually. So for now, we solve the one at pipe. So as you can see, at the pipe, it only have in y direction, so we will only solve in the y direction. So we get our first force. So TH is pointing upwards, so it's positive, and we minus with the weight of the pipe. W equal to mg. So m is 30 kg given in the questions, and g is 9.81 because this is constant for the gravity. So now we solve the second one at point A. This is A. So in the, as you can see, we get the value to 94.3 Newton for THA. So that means this is actually 294.3. So we can just directly substitute the numbers. Okay, since at point A we also have force that acting on the x direction, so we solve for that one. So when you guys solve for this one, you guys will get TA is equal to okay. So we settle with forces at pipe and also at point A. So now we will do the one at point B. Okay, so forces at 8B dekat at B in the y direction, since we already know the value of TBA, which is here, so we just substitute, and then from the equation you can solve for the value of TDB, which is equal to 490 Newton. So now we will do in the x direction. Okay, so forces at B in x directions, we have so TDB, we already know the value from here, and TA we know the value from here, and so we substitute the value into these equations, and then you guys solve it and you guys can get TCB equal to 562.3 Newton. Please remember to write the unit. Okay, so this is all there for questions number 3. And now, anyone has questions? Okay, if then I assume you guys clear with questions number 3. Okay, so now we will proceed with questions number 4. Okay. So you guys can take 5 to 10 minutes to solve for questions number 4, and then we will discuss together. So you guys have any problem with questions number 4? Okay. So since we don't have much time left, so we will discuss this together. Okay, so for questions number 4, the questions want us to So the question wants us to find the tension in each cable for equilibrium. So there is 3 cable we have to find, AD, AB, and also AC. So what we got to do at this situation is, first we have to find the coordinates for all 4 points A, B, C, and D. So okay. So from the questions, these are the coordinates that can be found from the diagram. A is 005, B is 440, C is -230, D is -4, -50. Okay. So for this question, you guys only need to use one formula, which is this one. So based on this one formula, we will find uh, three all three tensions, and there is actually force at A that pointing upward just now, which is in the 100 Newton. Okay. So we have to solve the tension one by one by using the mentioned formula. So F with a straight line up here is actually the vector force, because I could not make the letter to be bold, so I make a symbol there. So just so you guys know, equal to force. First we will settle for AB first. So our vector is actually the the difference between two coordinates. So basically we have force, we are looking for force vector force AB. So basically that means in x directions, so B have to minus with A coordinates. Okay, up until this point. So next we find a vector FAC. The same formula. So coordinate C minus coordinate A. So for vector force AC up until here. So next we will do vector force AD, which is coordinate. So for this one, coordinate D minus coordinate A. So when you guys solve this, you guys will get Okay, so this is the vector of forces for all tensions. So in order to find the tensions, we have to go to second step. Where force in x, y, z direction should be equal to 0. Okay. So basically what this means that okay, first we will solve in x direction first. So you guys just need to add force A, B, A, C and AD, the one with I vector that indicates in x direction. So okay, because there are three unknowns in here, so we have to simplify. So this is equation 1. Okay, now we go for Fy. So you guys need to add all forces in y direction from all three tension. And this one also have three different unknowns, so we simplify the equation. So this is equation 2. Okay, now we sub 1 into 2, or actually equal. Okay, basically we get then from this one, we simplify again the equation so that we can minimize as much as unknown that we can. So this is question 3. Then we sub 3 into 1 so that we would get the value of FAB. Okay, guys. This is equation 4. Now we solve for some force in z direction. And we plus with 800 Newton because there is one direction upward, go to 0. So this is 5. Now you guys sub 3 and 4 into 5. So from all this, so you guys see we only have one unknown, so we can directly solve for FAD equal to 565 Newton. Okay. And then since we already got AD, so from question 4, you guys will get FA 578 Newton. Then from question 3, guys get okay. So these are the answer. FAD equal to 565 Newton, FAB equal to 578 Newton, and FAC equal 5.8 Newton. Okay. It's kind of lengthy, but you guys can review it later because this I wrote at the whiteboard, so you guys can go to the whiteboard and see the questions again. And actually we have 12 minutes left, but actually we have another questions which is questions number 5. So since this is the questions number 5, so since we don't have much time left, so I guess we will have to do these questions together. Later I will share with you guys the questions and the answer you guys can find at the whiteboard in the chat, next to the chat. Okay, so so basically actually questions number 5 is almost as same as questions number 4. So we use the same formula. F vector equal to force times wave vector, and this equal to F times R vector over R. Okay. So for coordinate at A is 4, 0, 0. B is 0, 0, 0. C is 0, 3, 0. D is 2, 2, 1, 1. One negative one. Okay. So basically we solve for force vector force for AD. And for this one, the coordinate D has to minus with, I'm sorry, A has to minus D, because D is the position where A is the direction where the force go towards the. Now we solve for vector F BD. So the coordinate B minus coordinate D. Do you guys have any class after this? Because I think I'm going to need extra 10 minutes from you guys.
Yes, Miss, we have.
Oh really? If that's the case, when time is up, you guys can leave. You guys can leave, and I will post I will share the questions, and the answer you may find in the whiteboard. The whiteboard is in the chat, next to the chat. Few tabs next to the chat, so you guys can refer there. Okay.
Okay, thank you, Miss.
So basically it's the same as questions number 4, but different values. So I think we should not have much problems. So for first CD, the first C have the coordinate C have to minus coordinate D. So and when you review and you guys have questions, you guys can leave the questions in the chat and I will try to reply. And then we have a value of weight actually. W equal to mg. Because it's in negative direction, so we might use minus sign. Okay, now we all have the vector of the forces. Now we can sum the forces according to their axis. So it's already 12, so who has class, you guys can leave right now. So you guys can review the answer and questions later. And you guys have questions, you guys can just leave the questions in the chat. Okay, thank you. The one who doesn't have class, you guys continue.
Thank you.
And for those who do not left, uh, kindly borrow me your time about 10 minutes so that we can finish up these questions. So for the force in the x-axis, when you sum them up and then we simplify the equations. So this is equation 1. Now we solve in the force, we sum all the forces in the y-axis. So this one also we simplify the equation. This is equation 2. Then you guys sub equation 1 into equation 2. Or actually 1 equal to 2 because both is FAD. And from here you guys can get FB equal to 0.4084 FCD. So this is equation 3. Then guys sub equation 3 into So this is equation 4. Then we solve our forces in z direction. So negative 1275.3 is the weight in the opposite in negative direction. So this is question 5. So just so you guys so 3 4 into 5. So when you guys solve equation 4, 3 and 4 into 5, you guys will get FCD equal to 1275.3 Newton. And then from equation 3, guys will get FBD equal to 5 to 0.8 Newton. So from equation 4, you guys will get FAD equal to 156.2.1 Newton. So these are the answers. So these are the answers, kinda lengthy. So I hope you guys will review the answer later. I will touch up a little bit so that it will be about readable. So if you guys have any question, you guys can ask now. Okay, if you guys don't have any questions, then later, if later you guys review and you guys have questions, you guys can ask me later. Okay, and thank you for borrowing me your 10 minutes, and thank you for attending class. I will share the questions later. If you guys don't have any questions, you may dismiss. Thank you.